Okay, so nothing different from chapter P. Let's roll over that stuff pretty quick. Let's get into what we're doing. Now, I do want to say this. I'm going to go ahead and skip number 2, because you've done it. It's on the last test. Now, number 1, though, this is a little unique, okay? This was on the last test, and I set it up so you get used to these ratios, but now that we've been through the unit circle so much, what is that angle?
45.
And if that's 45, I mean, boom, some of this stuff should just start being automatic. Alright? Sine is square root of 2 over 2, because I know the y value on the unit circle is square root of 2 over 2. Is the y value here square root of 2 over 2? Okay. Am I on the unit circle, though? Kind of a trick question how I phrase that. This triangle is not on the unit circle. This is going forward 4 in the coordinate plane and up 4. Remember, the unit circle, everything has a hypotenuse of 1. So that's why you may go, well, wait a minute, the sine of the angle is not equal to y, because y is 4, okay? That is only on the unit circle, because remember, the unit circle, everywhere the sine is equal to opposite over hypotenuse. But on the unit circle, what's unique about it is what's your hypotenuse everywhere?
1.
Alright, that's why on the unit circle, it's the opposite. The sine is just the opposite, and what's always the opposite is just the y value. So don't go to these problems and go, oh, the sine is 4, and the cosine is 4. Okay, it's not the x and the y value here. We've got to get those two worlds separate. Now, you are still going to get a ratio of square root of 2 over 2, though. If I did Pythagorean theorem here, I get square root of 32. Square root of 32 simplifies to 4 square root of 2. And if I did the opposite over the hypotenuse, 4 over 4 square root of 2, look at what that simplifies to. 1 over square root of 2. Rationalize your denominator, square root of 2 over 2. I get the exact same answer. But if you notice right away, hey, you know what, that's on the unit circle, well, go with it then. Then you know all this stuff about it. Square root of 2 over 2, that's 1, that's 1, that's square root of 2, that's square root of 2. And you don't have to go figuring out all this stuff like you did in the last chapter. Now, I pushed you to go through that stuff then, and to see those numbers. Now we're getting really used to them, okay? Now, number 2 wasn't on the unit circle, but again, we did number 2 last chapter. But you can't just jump to these answers, okay? Alright, just want to say that. But if you can do these other ones, there's no reason to go into number 2. Alright, here's where we're taking this a step further than I did last chapter. And then we really incorporate down on number 5 and 6 what we're really doing this chapter. But on number 3 and 4 is where we take it a step further. Okay, you're in the coordinate plane. With that, we have positive and negative values. That's the only thing that's different is you got positive and negative values. So when I'm over here in quadrant 2, I know that I'd move backwards and up. I would go ahead and draw that triangle. There's not really good room there to do it with what they've already drawn. But that's negative 4, that's positive 1. Alright, now pretty automatic for you guys, especially after the last chapter. What's the hypotenuse? Square root of 17. Is that something off the unit circle? Nah, we didn't mess with any square root of 17s. So, because I'm not familiar with that, I'm going to have to go through and, again, background knowledge, state what sine, cosine, tangent, and all that stuff is. But make sure, let me bring up something from yesterday, because this is going to affect us in a little bit. All students take calculus. Before I even start this problem, what is the only of sine, cosine, and tangent? What's the only thing that I already know is going to be positive? Good. I'm in quadrant 2. My y value is positive. So I can tell you right away that cosine and tangent are going to be negative. This is one more time for me to repeat this. If sine is positive, is cosecant positive or is it negative? Alright, remember that. I'm telling you, that's going to mess with some of your heads later. Remember that. So cosine's negative, secant's negative. Tangent's negative, cotangent's negative. I know that before I even start the problem or even mess with numbers, just by knowing that I'm in quadrant 2. Alright, so let's see if I can try to go a little faster with naming these ratios without doing a bunch of work, and I'll talk you through it. So sine, opposite over hypotenuse. Okay, here's what I'm over square root of 17, but I've done so many of those now. Multiply top and bottom by square root of 17, so it's square root of 17 over 17. I think you'll get really quick at that. Cosecant, though, I'm not going to flip that one over. I'll flip this one over. That's easier to look at. It's just square root of 17. Cosine, -4 over the hypotenuse. Okay, -4 over square root of 17. That's -4 square root of 17 over 17. Again, we're so used to rationalizing the denominator. I told you you're going to do it a ton of times in this class. Secant, flip that original one over, square root of 17 over 4. Tangent's easy, opposite over adjacent, 1/4 and 4. Alright, so let's have you do one. Let's make sure you draw it in the right quadrant. And let's make sure you get the right positives and negatives. I will say this one works out very nice and neat. Because 8, 15, you know what the triple is with that? It's a Pythagorean triple. Anybody? 8, 15. Alright, you can figure it out on your calculator. 8, 15, 17. 8, 15, 17. But go ahead and draw it in the right quadrant and answer those questions about it. What's nice about that is it doesn't have a radical. It's a triple that works out nice and neat. Alright, so what quadrant are you in? Very good. Forward 8, down 15. Hypotenuse is 17. Hey, this is the time I should mention in both of these, your hypotenuse is positive. It will be positive in everything we do until we get to vectors. And then in vectors, we'll talk about having a negative hypotenuse. But it's the very last chapter in trig. Don't worry about it right now. Hypotenuse is always positive. Alright, so from this angle, the sine is the opposite over the hypotenuse. So -15 over 17, flip it. 17 over 15, cosine's 8 over 17. I already knew cosine was going to be positive because I'm in quadrant 4. Cosine's positive. Again, that's one of the biggest things people miss on this next test is just little things with negatives. Tangent opposite over adjacent, -15 over 8, flip it, -8 over 15. Alright? Got it. Okay, now we really get to the trig stuff and why this is coming up in this chapter. 3 and 4, again, they build on last chapter to put a position in there, but here's the important part. Alright, we'll cover this up for just a second and talk about this. Okay, cosine is -4/5. Alright, so think about that one more time in regards to, write down, all students take calculus. Okay? So if they tell you that the cosine is negative, where could I be? 2 or 3? Alright, that needs to really stick out in your brain. Okay, so let's pause there for just a second. If they left it at that, because this is where we're going later this chapter, if they left you at telling you the cosine is -4/5, I don't know where to draw the triangle. I don't know to draw it in 2 or to draw it in 3. And I can't, it could be either one, because both places there's a triangle that exists that the cosine is a -4/5. Okay? So, if they want you to draw one triangle, they have got to give you more information. They got to tell you which of these two spots I'm in. This right here tells me I'm either in 2 or 3, but they got to give me some other information. And this is why I taught what I did yesterday on the quadrants and all those characteristics. That's why I taught you the ASTC. That's where it comes into play. So this is the second piece of information they give you. Well, the first one just totally gives it away and says, put it in 3. Thanks. All right. But you can see in number 6, they don't just give it away. They ask a question like yesterday that says cosecant's positive, cosine's negative. So you got to go figure out where to draw it. All right? All right, so this is where we really get into trig here. So I need to go over to quadrant 3. I need to draw a triangle where my adjacent is -4 and my hypotenuse is 5. Alright, so I'm going to draw this triangle where I've got a -4 and my hypotenuse is 5. Well, again, it's Pythagorean theorem, but we don't need a calculator for this one. What's your missing side of that triangle? Alright, good. And some people at first, they're going, what's popping in your brain is 3. Number one mistake on the next test that we will have next week, into next week or beginning of the following, right in there. This right here, star it, highlight it really big, maybe even say, remember the negative. Okay? Pythagorean theorem tells you that you take the square root of something. When you take the square root, it's plus or minus. Most of the context with Pythagorean theorem, it's a positive. If you're finding the hypotenuse, it's always positive. It's always positive when it comes to hypotenuse. But if you know a position in the coordinate plane, and that position is in quadrant 3, then both x and y have to be negative. If you go through and answer all these questions with a positive 3 here and a negative 4 there, you're going to have all kinds of negative signs off in here because all students take calculus still applies. But right now, if I took my tangent, well, that'd be positive divided by negative. My tangent would be negative. But with all students take calculus, tangent should be positive. Okay? Be careful on this one. Just always double check on these signs. That's going to be the thing that's missed. And it's not that you don't know it conceptually. That's not a hard concept. It's easy to forget. Alright, so be careful with that. Answering all these should be real easy now. Sine of the angle is the opposite over the hypotenuse, negative 3/5. Cosecant would flip that. Cosine is negative 4/5. Secant would flip that. Tangent is negative divided by negative. I knew that was going to happen in quadrant 3. Very good. Positive 3/4. And then I flip it 4/3. Alright? And it does double check. I knew that tangent, the only thing positive, sine and cosine are negative. Alright. So put it all together, what we learned today and a chunk of what we did yesterday, and see if you can show me what quadrant this is and answer these questions about it. Now this does combine a lot of stuff together. I'm going to let you discover it on your own. But right away, I told you, every time I see cosecant, I don't want to think about cosecant. I want to do sine. So I'm doing sine of 1/8. I'm not doing cosecant, okay? That's how I think about it. Because if the cosecant's positive, the sine is positive. All right, draw that one in the correct quadrant, and make sure you can simplify your fractions and rationalize your denominator correctly. So you should be in quadrant 2. But there are two things wrong with my square root of 63. What's one of them?
Simplified.
Okay, simplified. Second one?
Not negative.
Negative. All right, those are the two errors that can happen on this next test that you got to watch out for. You are in quadrant 2, so your x value has got to be negative. You got to remember that. And the square root of 63, here's your background knowledge. This is stuff from algebra. This is what we missed on that quiz in chapter 1. That anytime you got a radical, I do expect that you can simplify it by now. That is 9 times 7. Square root of 9 is 3, so it's negative 3 square root of 7. That's how we need to write it. Okay? Now if you can write it like that, you should be good to go. But I wanted you to get that right before you filled all these in if you were missing something there. Okay, take a minute, fill out all those charts. We got one other little idea, degrees. Okay? So all of these will come from the unit circle. And when you see these characteristics, I want some, hey, I've seen a bunch of that. Tangent is 1, I know it's a 45-degree angle. Okay? I don't know where it is. It could be 45 degree into quadrant 1, or what's the other quadrant I could be in if it's positive 1? Alright, so let's actually write that down. This is telling me I'm in either in 1 or 3. But remember, so I could be 45 or I could be over there at 225. Okay? Then they give me a second piece of information. Here's the second piece of information. Because again, if all I know is the tangent's 1, I don't know which place I'm at. They tell me the sine is negative. Alright, so there's the second piece. If sine is negative, and if you'd like to, write real big, all students take calculus. We're going to use that a bunch. So if sine is negative, where am I at? 3 or 4. And the overlap, I got to be in 3. Alright, so I'm in quadrant 3. Well, let's draw that. Let's draw quadrant 3, because we were using this skill on the front. 45-degree angle into quadrant 3. And let's look at their actual question, because I can tell you all kinds of stuff about this. I can tell you sine, cosine, tangent, secant. I can tell any of that. I can tell what angle I'm at. If they ask what angle you're at, I'm at 180 plus 45, I'm at 225. I can tell you anything about that. I know all those characteristics now, and again, I'm just envisioning them in my head, but you can break out your unit circle if you need to right now. Alright, here's their actual question. What is the cosine there? Well, the cosine right there, with the angle that we're talking about in that position, is the x value right there. The x value is square root of 2 over 2. But what quadrant am I in? So what's wrong with that? Don't forget the negative. Be careful. There's the answer to their question. Alright? Okay. See if you can do number 8. Again, try to do it without looking at your unit circle. Alright? What's going on automatic? What am I thinking of there? What angle is that? When the y value is the larger one. Good. Think of the 60-degree triangle, but again, I don't know if it's 60 in quadrant 1, 60 in the quadrant 2, 3, or 4. This is where reference angles are coming into play. And characteristics of quadrants. All that stuff is coming together here. Your unit circle, all that. This is good. It's good. Okay, so if sine is positive, what quadrant could I be in?
1 or 2.
Okay. If cosine is negative, what quadrant could I be in?
2 or 3.
So where do I have to be?
2.
Okay, gotta be in quadrant 2. So I'm gonna draw it. I'm gonna go over to quadrant 2. I'm gonna draw the 60-degree triangle in quadrant 2. This is 60 degrees. Alright. Now, what do they ask me? It's an easier one. They just asked me the angle. Okay? That angle, when I go 60 degrees up from 180, the angle is 120 degrees. Now, technically, from the beginning, I think you're still more comfortable with degrees. You could have said that theta was pi over 3. I don't think any of you are thinking that default way, and you don't really like fractions right now. But you could have said that. And I could go pi over 3 up from pi, so I could give the same answer as 2 pi over 3. I would take either of those answers. I'm not requiring both right now, but know that if the direction said give your answer in degrees and radians, you'd have to state it both ways. And I will throw some of that stuff at you at times. That'll say, give your answer in radians and degrees. So then you'd have to. I'm not asking for that now. So you can state either one, but I could. Alright, there it is.